Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about a few basic concepts about set theory. In our last class, we have given the introduction to set theory. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, this is very simple class to understand. We will discuss about different definitions. What we call it as a null set. A set that does not contain, it should not contain any element is called as null set. If that set does not contain any of the elements, then we call it as null set. A is equal to, this set contains no elements. We call it as a null set. A equal to, null set can be mentioned using other symbol. We call it as phi. You can mention like this, or phi you can use it. One more example in the other way, b is equal to x. X is an integer and 2 less than x less than 3. This is the condition it has to satisfy. Means you should find an integer that lies between 2 and 3. An integer between 2 and 3. Is there any integer between 2 and 3? No, we don't have any integer between 2 and 3. So this set is an empty set. Empty set means null set. It does not contain any of the elements. Now coming to the next definition, universal set. When we say it as a universal set, a set is said to be universal set if it contains every set under discussion. Means you take any of the elements, all the elements should be present in this set. Then we call it as a universal set. In our previous unit in propositional logic, we discussed about universe of discourse. Means a set that contains all the elements present in this universe. That we call it as a universe of discourse. Same thing here. Universe of discourse means every element present in that set. Same way, universal set means same. You take any element that should be present in the set. That can be, you mention the universal set using a capital U or capital E. You consider it as universal set. Now coming to the next example, subset, or we call it a set inclusion. X and Y are two sets. If you take any two sets, if every element of X is an element of Y, then X is subset of Y. The symbol for subset is given as X subset of Y. Understand it properly. If every element of X, whatever the element that present in X, it should be present in Y. Then X is subset of Y. And one more important point you need to understand, with example we are going to understand, X is equal to A, B, C. Whatever the element that present in X, it should be present in Y. A, B, C present in Y. Y can contain more elements also. We don't bother about that condition. Whatever the elements that present in Y, we bother about the condition. Whatever the elements that present in X, those elements should be present in Y. If that happens, then X is subset of Y. Now we are going to understand some properties about a subset. Properties of set inclusion. Every set is subset of itself. Yes, it is accepted because A subset of A. What is the condition of subset? Whatever the element present in A, that element should present in A itself. Yes, it will be A, B, C. A subset of A. Whatever the element present here, it should be present in A. It happens, A, B, C. So, A subset of A. This is the first property. This property we call it as reflexive property. Now coming to the second property, an empty set is subset of every set. You take any set, it is empty set is a subset of, you take any set. Why? Because what's the condition says, whatever the elements that present in the set, it should be present in the Y set. If there are no elements, what happens? The definition does not saying anything about if there are no elements. Means it is satisfying the condition. So A is equal to 5 means empty set. B is equal to A comma B. Yes, A subset of B. Because B can have any extra elements. Yes, this B is having extra elements. What's that elements? A comma B. So that's why A subset of B. An empty set is a subset of every set. You take any set, it is a empty set is subset of any set. Now coming to the third property, set inclusion is transitive. Transitive means, let's take if A subset of B and B subset of C, then A subset of C. If it satisfies this property, then we call it as it is transitive dependency. Transitive means A subset of B and B subset of C, then we can say that A subset of C. Yes, this is happen. A subset is a transitive property. With example, we are taking this. A is equal to A comma B, B is equal to A B C, C is equal to A B C D. A subset of B, B subset of C, then A is subset of C. So subset is following the property called transitive property. Now coming to the proper subset or proper inclusion. So you need to understand it properly. X and Y are two sets. You take any two sets. X proper subset of Y. When we are going to say that X is proper subset of Y, if X should be subset of Y, X should be subset of Y, and at least one element extra needed in Y. In Y's, there should be at least one extra element when compared to the elements that present in X. Then only we say that X is proper subset of Y. Let's take an example. X is equal to ABC, Y is equal to ABCD. Yes, X proper subsets Y. Proper subset symbol is, this is the symbol given for proper subset. X is having ABC, Y is having ABC. At least one extra element should present in Y. Yes, D is there. Then we call it as X proper subset of Y. Let's take this X ABC, Y ABC. It is not proper subset of Y, because Y should have at least one extra element. So based on this example, you can define one more condition for proper subset. What's that condition is? Another way we can say it as X proper subset of Y. If X subset of Y and X not equal to Y, then only at least one extra element will be present in Y. X is not equal to Y. Then we say it as X proper subset of Y. So coming to the properties of this, X not equal to means here not a proper subset for X. The definition itself says X proper set of X. No, it is not accepted, because one extra element should be present here. X, same elements, which is not accepted. So not reflexive. Proper subset is not a reflexive property. Second one is proper subset is transitive. Means X proper subset of Y and Y proper subset of Z, then X proper subset of Z. Yes, this happens. We are not giving any example for this because you already have the understanding from subset. You try it on your own. If you really want to, if you have any questions, you take any example, you will get the idea. Hope you understand these basic concepts about sets and set theory. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.